Welcome to Ask and Learn.
So in this problem, we have an escalator that moves with a velocity of 0.6 meters per second. And we want to find the power it takes to move somebody that has a mass of 150 kilograms. So we're given a few pieces of information. So we know that the height of each little step is 125 millimeters. If we divide by 1,000, we get 0.125 meters. We're also given the length of each little step, which is 250 millimeters. And if we divide that one by 1,000, we get 0.250 meters. So now we want to find the actual height of the entire escalator. And we're told that there are 32 steps in total. So if you want to find the true height of the escalator, we have the number of each step times the height of these steps. So it's 32 times 0.125. So the height of the entire escalator is actually 4 meters. So let's draw a little triangle out. So we know that the height of this escalator is 4 meters. Well, the length will be the length of each individual step times the number of how many steps there are. So for the length, we have 32, the number of steps, times the length of each step, which is 0.25. And now if we want to find the hypotenuse, we use the Pythagorean theorem. So let's call it hypotenuse z. So we have 32 times 0.25 squared plus the 4 squared and all of this square root. So for z, we have 8.9 meters. Z is equal to 8.9 meters. This is the distance that a person travels going up an escalator. So we know that power is equal to the force times the velocity, but because we're going up a slope, the velocity is in the y direction. And we know that the velocity in the y direction is actually v sine theta. We're going by the triangle. We know that sine theta is 4 divided by 8.9. So now if we plug this back in for power and the other variables we know, we have P for power is equal to the force. We know that the force here is the weight, and the weight is mass times gravity. So 150 for the mass times 9.8, but this mass is being carried 32 times up this escalator. So it's actually the weight times the number of each individual step. And then times the velocity, which we know 0.6, times sine theta, which we know is 4 divided by 8.9. So we have P, the power it takes to move somebody up the escalator, is 12.6 kilowatts.